So this is our physics project. The people in my group are Sean William Butt, Connor Gerard McInnesby, and myself, Anthony William Metzler. Um, so to kind of start off on our project, we want to figure out what happened. Basically, what happened was Mr. Souza was driving down the road in his 2005 Dodge Ram 1500, probably texting while driving, and going on a hairpin turn. There was wet pavement, and it was a 20-mile-per-hour zone. Also, on said hairpin turn was Mr. Alan Chuckran. He was hanging out in his 2000 Jeep Grand Cherokee. We can assume, pretty much, that Mr. Chuckran's hanging out with Creep, hanging out a little bit, and they were watching a sunrise. And as they're watching the sunrise, they realized something turned horribly wrong. When Mr. Souza looked up, he realized all of a sudden that he was about to bang into Mr. Chuckran. So he slammed on his brakes, skidding on the pavement, and bam, he ends up hitting our dear Mr. Chuckran and bashing into him with his truck. Said truck and Jeep together fell off the cliff that Mr. Chuckran was on this hairpin turn, and they fell off to the bottom of the cliff and landed on the bottom. But there's no need to panic. Both were A-okay. No bumps, no bruises. Very clean accident. So let's kind of bring it down to our objective here. Pretty much the objective was to find out if Mr. Souza was speeding. We were given a full-scale model in class, and we were told to do some research. The first thing we kind of had to research was just kind of specific things that go along with Dodge and Jeep, including the weight and the length. You can see the weight and the length there. And we had to figure out scale. So to figure out scale, we ended up measuring one of the cars here and the skid mark. And, we used some pretty simple math, and we ended up figuring out that 41.91 was sort of the magic number there. That's pretty much what we had to multiply things by to get to a proper scale. So when we started our project, we couldn't do it the conventional way. We were told in class that we should probably start backwards. It makes the project much easier. So we started backwards, and we had to start off with a projectile that is, goes off a cliff. I just want to point out right now that this picture right here, it means nothing. It represents no data. It doesn't represent accurately what we were actually looking at. It was just a picture to give an example of what we were actually doing for the project at this point. To kind of move on, we were given a couple of variables. We were given the y, and we figured out vy naught, and acceleration, as always, at the gravity constant, negative 9.8. And what we didn't have was time. So we ended up using the second kinematic equation and to figure out our time. And we figured out, using some pretty hard math, that our time was approximately 2.85 seconds. And after that, we had to figure out something else. We had to figure out Vx. And using x equals Vxt, we figured out Vx is like 14 meters per second. And then we had to move on to the next part of the problem, which was a conservation and momentum problem, which was big fish, little fish, as we call it in class. So using our equation for that, we had to figure out VJD. We used J, the subscript J, to represent Jeep, and the subscript D to represent the Dodge Ram. So using pretty hard math again, we ended up figuring out that VJD was 22.8 meters per second. And then we had to figure out the final stage of the project is figuring out how Speedy Gonzalez, aka Mr. Souza, did, and what he did. So using conservation of energy problem, we used EK equals E therm plus EK, and we ended up figuring out, using that pretty hard math again, that our velocity equaled about 58.1 miles per hour, which was very, very fast. This is actually, it's enough to get him a ticket, and it's way, way too fast to be driving on a hairpin turn when it's wet. For this project, we worked pretty hard. So just wanted to point out one little fact. This guy, less than these guys. I hope this helps.